All right. So, welcome to what day is this? Week two, day two, I think, of uniform. Let's see if I can start sharing my screen. Once I find the right screen share. Or come on, where's Zoom? There we go. Cool. All right. So, happy Wednesday. Today we're going to be talking a little bit about intermediate OOP methods. So we've got a few things on the list. So I know yesterday you guys talked a lot about classes. We're going to be building off of that today. So we're going to kick things off by talking a little bit about instance and class attributes, which is something that we discussed that you guys discussed briefly yesterday with Francisco. Then we're going to jump into instance and class methods, which are kind of like the next step. We're going to talk about these weird things called decorators, and then getter and setter functions. So, before we kick things off, does anybody have questions relating to anything class like this, like Platoon class or like Python classes related before we jump into today's material?
Yeah, I have a quick one. Can you re-explain the Dunder method? That just confuses me for some reason.
Sure. So, all right, now let me switch to my VS Code. And where's my screen share? Screen share. VS Code. Okay. Can you all see my screen okay? All right, cool. So Dunder methods are basically things that let us use, I guess you could say like built-in functions for classes, but like custom set them, right? So if I wanted to define, let's say class, let's call this thing my class, and the Dunder method that you basically will always use, except in maybe one or two cases, is an init method, right? So the way we know it's a Dunder method is because it has the double underscores at the beginning and the double underscores at the end. So if you do, define init self, this is a Dunder method. Why is it a Dunder method? Well, because it overwrites whatever default behavior you have for instantiating a class. So I don't know, let's say that um, we had a class that took, I don't know, favorite food, and we could say self dot fav food equals your info. Super simple. So yeah, the init method is a Dunder method because it overwrites our default behavior. Now, what we could do is let's say, I don't know, I like bananas equals a new instance of my class, and your favorite food is bananas. So we have this class. Now let's say that I want to print out I like bananas. What do you guys think is going to happen when I print this out?
It's going to print the memory space.
Exactly. Right. And if we run this and my code decides not to break, we get this weird output. And well, it's not exactly weird. We can break it down, right? The first thing it says is that we're getting a my class object from main, and it gives us our memory address, as you stated, Ethan. But this doesn't tell us anything about what's inside of this class, what stuff it does. So we can create a new Dunder method um, called our string function itself. So what the string Dunder method does is this will basically controls what happens when my class gets turned into a string. So what do I mean by that? Well, we could print out, str of my class, but str of my class will return essentially what we printed, which is this weird string of returning an object. That doesn't tell us. But what we could do by defining our own custom string method using this dunder method. We could say like return, I really like, and then plus self dot fav. So if we run this now, by printing I like bananas, we can't just print out a class because Python doesn't know how to print a class. So default is saying, all right, I'm going to go and print out the string method of this class. Ordinarily, the string method for a class will print out the memory object of it. However, in this case, str, our custom dunder method, overwrites the regular traditional one. And because of that, once we print out I like bananas, this should probably, hopefully, once it runs, print out our custom definition for our string method of I really like bananas. So dunder methods are really useful for overwriting like regular behavior. We can also make another dunder method called like, so you can have a dunder method for addition of two classes, subtraction. Pretty sure that there are others, but the main ones that you usually will see are init and string. But for majority of Python's built-in functions, and there's definitely a list of all the dunder methods that you can include floating out there on the web. But for any of those, we can custom overwrite it using dunder methods. So that's really where they come in handy. So does that answer your question?
Yep, thank you.
Yep. Anybody have questions about dunder methods or other class related things?
Question. Usually, my first time hearing about this, they use like magic method. Is it the same thing as a dunder method, correct?
What do you mean by magic methods?
So like the init construction right here. So when I learn about it, they refer to it as the magic method. Like,
Okay. Yeah. Yep. So those are the same thing. They're just different names. But yes, the most common name for it is dunder method. But dunder method and init method or dunder method and magic method are basically the same. But I would generally refer to it as a dunder method just because that's like the proper name, I suppose. Any other questions?
Is banana your favorite fruit?
It is definitely not. That was the only thing that came to mind. All right, so let's jump back to the slides. Okay, I'm assuming everyone can now see the slide deck again. Maybe, hopefully.
Yes.
Cool.
Yeah.
All right. So, we're gonna jump into some of the other material from yesterday. So the first thing that I want to talk about are classes and instances of classes. So real quick, can somebody tell me what a class is? Or or I guess describe what a class is. Like, what is a class to you?
It's a template.
Okay, that's a pretty good explanation. Yeah. So it's a template. Anyone else have anything they want to add?
It's like
I
a
would
recipe.
say like a container, like it contains similar, like something common within everything that's made within it, like class animals is a good example.
It's like instructions or like a recipe. Like if you want to build something, like yesterday we built a dog. You know, you can build it by knowing like giving it a breed and an age and stuff like that. So
Yeah, I think those are pretty good explanations.
It's
Oh,
your
go ahead.
Dungeons and Dragons guidebook, and then when you make your character, that's an instance.
Nice, because my next question was going to be, what's the difference between a class and instance? So you already hit that. But yeah, so as you guys have all collectively said, right, a class is basically, and think of it like a constructor or like a storage bin or just like a thing that we can use to store shared characteristics. But an instance is sort of like a D&D character sheet or like a specific variation of that class that we can manipulate. So like if the class, for example, is like a recipe, I guess an instance would be like the thing that you make by following the recipe or by filling it out or something like that. So what's the difference, I guess, now between class class attributes and instance attributes? So class attributes, as it says on the slide, can be accessed by all instances of the class. So if we have, and again, we'll jump back into this in VS Code in like a minute or so. But if we define something as a class attribute, and we'll jump into methods after, a class attribute can be accessed by any instance of the class. And so, for example, like all dogs have 4 legs, and we can set that as a class attribute. However, an instance attribute is something that's either generally instantiated using the init method or something that it can only be set, accessed, changed by a specific instance of the class. So let me jump into VS Code again. Here we go, VS Code. Perfect. So let's not do the dog class this time since you guys already did that yesterday. Let's delete this and let's say we have another common example is going to be the car class. So the first thing that we want to do is let's attributes of a car. So real quick, what are some things that cars have?
Tires.
Make,
All right,
model,
let's do that one at a time.
color,
All right.
Wheels.
make,
Year. Like a which year, yeah. Model.
Okay. Let's do one more.
VIN number.
Okay. I'm gonna do license plate instead. But that's a good one. All right. So let's go back to our car class. So, or you know what? Here, let's say that this is going to be even more specific, or let's say this is going to be even more specific. Let's say that instead of just cars, these are all going to be, well, let's say you're running like a Ford dealership, for example. So the only cars you have are Ford cars. So let's talk about how we can divide up these attributes. So how do I set something as a instance attribute? And how do I set something as a class attribute? Any ideas?
I think for a class attribute, you have to put it in the first like def init.
Okay, so that's close, but the things that we put into the def init are actually the instance attributes. But here's why. So whatever we put inside of the def init is something that we need to specify when we are creating a new instance of that class, right? So let's kick things off just as an example. Is color going to be a class attribute or an instance attribute?
Instance.
Instance. Okay. Now let's see why. Now let me do this and we'll go say instance. So let's say that we first set color up here, right? And we just wrote color. Now, it says this thing isn't defined. So, okay, we've got a tiny little bit of a problem there. So we need to now define color. And let's say that this color is, we have a red Ford, right? So now let me create a new Ford car. And let's say we have, let's call this my car is going to be a Ford car. And if we want to print my car dot color, what do you guys think this should output?
Red.
Red, right? Okay, and why is that? Okay, that was weird. It just, my console just started running something. Okay, there we go. So if we run this and wait for my computer to come alive, we see that this does indeed return red. Now, I can make another car. Let's say I have, instead now I have a blue car. And I don't have any way to set the color just yet. Let's say I'm creating this car. It's going to be a blue car. But when I print out the blue car's color, this also returns red. Why? Because we've defined color here apart from the init method. When we're defining it apart from the init method, we can't change color right now by passing in what the color is. We're just automatically setting it, which is what makes this a class method. So something I like to do whenever I'm creating a class is just define my class variables up here, and then right here, just write a note that says instance variables. Just so that way I remember where to put each one, but also that way I also like to generally make this sort of a little table before I make a class and share, like just write down, okay, what are the variables I need? What are the functions I need? And then start programming them. So that way it really helps to organize your code more smoothly, but also it just makes it easier to use. So as you guys all said, color is going to be an instance variable. So what we need to do in order to make it an instance variable is we're going to pass in color from the outside. And now we say self.color equals the color that I pass in. All right, let's keep going down the list. Now, what about wheels? Is wheels going to be an instance variable or a class variable?
Class,
Okay, why do you say it's a class variable, Jesse?
because they're all gonna have wheel. I mean, I guess unless we're like specifying like sizes or something with them.
Here, let me say number of wheels.
Then I would say class.
Okay, so why would it be a class variable?
Because they should all have 4.
Yep, perfect. So class variable, so we can set that up here. We can just say, just to be more specific, we can say num wheels equals 4. Now the type of wheels, the size of wheels, the rims, whatever, those are obviously not going to be standard across all of the Fords in our dealership. So that would be an instance variable. But I'm pretty sure that most Fords generally come with 4 wheels, or excluding spares and things on the back and all that. So we can set number of wheels to be a class variable because this is consistent across all Fords, right? So just to show an example of how this works very briefly, let's say that I'm going to make my car a silver Ford, and this blue one is going to be a blue Ford. So if I run this code now, because we were defining color as an instance variable, we see that we can custom set its value and customize it for each instance. But if I want to check the number of wheels on both of these cars that we didn't set, we see by default the number of values is 4, right? The number of wheels is 4. Why? Because we set that as a class variable to show the number of wheels on board this car is always going to be 4 unless we change it or do something else. So similarly, right? Because all of our cars are Fords, we can make the make of this car also a class variable, right? So we can say like make is Ford. Year is probably something that we're going to need to custom set. And so we could say plate number is also something we could custom set. You can say self.year is year, self.plate number equals plate number.
Is there a
any
difference?
question? Oh, good.
Sorry, is there a difference? I feel like I've seen, I thought they were class attributes, but they were passed in, or not passed in, but like written within the definite method. But like they're not something actually passed in like on line 6, but like where line 10 is, it would say num wheels equal 4. Or like, I don't know, like maybe contacts. Yesterday we did like contacts with like a dictionary, like an empty dictionary. Are those just ones that, like, what's the difference between those and a class attribute, I guess?
So there shouldn't be a difference between those. I think those are class attributes as well, because again, the instance attributes are solely dependent, like instance to instance, but the class variables don't depend on the instance. They stay constant. So if you were to move, for example, this guy into here, this should still give you the same thing. But yes, Francisco, go ahead.
Yeah, and I'm so sorry, Umar. I'm not contradicting Umar whatsoever. It's just that during yesterday's lesson, the difference is, so when we put the contacts variable inside of the init method inside of line 10, that was making context something that was unique to each individual instance. So even though they were all receiving the same dictionary, when I changed the value of that dictionary, that value change only happened to that instance. If I had a dictionary at the class level and I make a change from whatever instance has access to that class level attribute, that class level attribute changes for all instances all across. So if all instances check that attribute that belongs to the class, they can see that change. While the one that I made in the init method only belongs to that specific instance. Does that make sense, Jesse?
I think so. So we're never putting like, I don't even know if default's the right word, but like any kind of class attribute in the definite. It should always be like above the definite, like right under class.
Right. So something that you want to apply to the class should be not inside of the init method, right above it. Something that you want to apply to the instance should always be inside of the init method.
Okay, thank you.
So is the reason that you had that as a dictionary, is that just because you could have anywhere from like 0 to 100 context, whereas things like in this example, color can only be one color. I guess it could be more than one, I suppose, but then year can only be 1 year, plate number, so on. Those only can have one value, whereas contacts can be multiple. Is that why you had that as like an empty dictionary?
Yeah, so I specifically chose an empty dictionary because I was thinking, well, if I needed to store contacts, I need a way to easily get them. And I know that the .get method would get me a contact out of a dictionary rather than having to do a filter through a list, try to find the correct one, pull the correct one, then utilize that. Dictionary was just a better data structure for storing information. Does that answer your question?
It does, thank you.
Hey, Francisco, just for clarification, if you would have put context outside of the definite method, kind of like how we have, like you guys were just discussing, when you do instantiate different classes, then would that always instantiate like an empty dictionary, and it wouldn't affect it if you would instantiate different, multiple instances? They wouldn't affect each other, right? It would always start out as a blank dictionary.
So if you did it after line 4, can you just make different models and have like a list, Umar?
Sure. So make a new class.
No, not a new class. Just make it, just call it like different models and then make it a list. Okay, so that would be something that applies to the entire class, right? And now inside of line 11, or right after line 11, could you make something like self.drivers and then make that a list? Okay, so right now we have my car. Okay, could you take off driver one real quick? Yeah, so right now we have my car, right? And then after my car, could you press enter and then do, oh, what's going on?
I'm just making it easier so I don't have to keep typing.
Oh, okay, cool. Nice. Yeah, so after my car on line 15, or yeah, could you do my car dot drivers dot append and then just add a driver in there? And then could you instantiate a different car right after line 14? Just so that we have two of them. Oh, you already have another one. Nice. So after line 18, could you do blue car dot drivers dot append and then just do driver 2? And then in the print statements, could you just print the drivers? Yeah, thank you. Okay, so now when you run this, right, we're going to see two lists. And we see how the list that belongs to the first instance only has driver 1, right? And the list that belongs to the second instance only has driver 2. Well, now if we were to move the drivers list, or actually we have that different models. So on line, after line 15, could you do my car dot different models dot append? And I don't know, Mark, can you just add something in there? Yeah, thank you so much. Okay, and then on line 21, oh no, don't append anything in there. On line 21, could you just print blue card dot different models? Okay, so this is happening on two separate instances, right? So we have our my car is appending a model, and we have blue car not touching the different models at all. But yet when I print different models from blue car, we see model 1, which happened in a separate instance, right? So because it happened at the class level, all of the instances that can access that class attribute can see that change. When before, any changes that we made only belong to the specific attribute. Does that answer your question?
Yes, it does. Thank you.
Of course. I'm so sorry that it was so hard to demonstrate that. Yeah. Sorry about that, Umar. I didn't mean to take over like that.
Sorry, one
No
more
problem at all.
question. That was really helpful. So they're still called like self.drivers with the empty list is an instance variable. But what's the difference between what, like, I guess what's it called when it's passed in like color or when it's just set like it is on line 10?
Well, that's technically just an attribute. Do you mean what is it called when I give it a value?
I guess like, so color is an instance variable that we're passing in, and then drivers is an instance variable that we're not passing in.
Yeah, so it's just an instance attribute that will stay pretty much as a constant for every single instance that gets instantiated. Yeah.
Okay. Thank you.
Of course, no problem. Thank you so much, Umar.
I had a question as far as the class attributes. So could we add like say 2 to the number of wheels, like if we were to call it down lower? Like I know where you said sorry. Where we had like dot number of wheels. Could we print number of wheels plus 2? Like would it, or
So we could do that, but that would do something very similar to what Francisco was just talking about. And thank you very much for that explanation, by the way. That would do something really similar to what we just did with like diff models. So where here we appended to diff models for my car, but because that is a class attribute, that changes it for everything else, right? So Chris, just to make sure, what you're saying is to say something like my car dot num wheels equals 6, right?
sort
Or
of?
are you saying something different?
I would just say plus 2. Like for some reason I was thinking that class attributes are more like permanent versus being able to change them around a little bit. But I was thinking we could just add to it in certain instances.
So you're right that in general, we don't really want to change the class attributes. So in Python, basically all variables can, well, let me rephrase that. For classes like this, most, if not all variables can be changed depending on scope and definition and such. But for right now, let's just say that all of these variables that we define within our class can be changed. However, we generally don't like changing class variables because, again, like the demonstration just showed, when you change the class variable, even if you're just changing it in one instance, right, just like we're doing with our my car diff models, that changes diff model, that changes our class attribute for all the other instances of the class. So again, just like instance attributes, class attributes can be changed. Should we change them? Generally not. If you know, for example, that let's say that Ford comes out with one new car that we know has 6 wheels instead of 4, and we know that we're going to be like using those, then we know that we're going to have an instance of this class whose num wheels is not always 4. So it's generally, if we have that, we could just define the number of wheels as an instance variable instead, just so that we can change it for each instance of that class. And yeah, even in general, that's what I would say. If there's any chance of changing it, it's just easier to define it as an instance variable.
Hey, Umar,
Gotcha.
is there any way to like lock the class variables? Because it just seems kind of crazy that like one instance can change the entire class. Is there a way to like make it a constant so that the only way you can change it is if you go back into the class itself? Especially like if you're working on this with multiple other people and one person just kind of slips up and ruins it for everybody.
I'm not sure actually. I don't think there is a way to lock it explicitly in the way that you're suggesting. But well, actually, there kind of is. So we're going to get to that probably close to the end, or I guess not the end, maybe in about an hour or an hour and a half. But we're going to talk a bit about getter and setter methods, which basically allow you to define how you get and set a variable. So, like, for example, right now, if I want to just like set the number of wheels, I could just go in here and just type like my car, or like I've done down here, my car dot num wheels equals 6. But let's say that I don't want to give people the ability to, I don't want to give people the ability to access that variable directly. So we can create a getter or a setter method to make it more convoluted so that they can't change the variable itself direct or like by calling it in this way. That's a little bit nebulous, but trust me when I say we'll get to this in today's lecture. But the simple answer to your question is there, as far as I'm aware, there is not a way to actually lock the value of a variable in Python like this. The complicated answer is you can make it harder for people to change it.
Makes sense. Thank you.
Yep. Any other questions? Let me just catch up on the chat here real quick as well. So yeah, so using the self dot notation basically refers to the instance itself. So for classes, whenever you use self dot, that means it's an instance related thing. Whenever you just use the general variable like this, that means it's class, like a class method or class attribute related thing. Okay, so now that we've defined our class, let me just write this down. This is going to be a class variable we'll just say note changing one of a class variable for one instance changes it for all. We could say changing for one instance only affects that instance. Nope, there's one I in instance. There we go. Okay, so here, so let me just move this just to make things a little bit cleaner. Perfect. All right, so now we've talked about
My
class.
screen is stuck.
Oh, whoops. Here, let me try that. Does that work?
Yeah, thanks.
Okay. Yep. I think hit the screen pause by accident. So now that we've talked about instance and class variables slash attributes, let's also move on to talking about instance and class methods. So an instance method is basically just the simple way that we define a method normally, right? So let's say for our car, we could have, I don't know, say define, what's a good instance method we can use? We could say make it purple, and we could say self, and then we would say self.color, and now changes to purple. So what does this do? This is going to change the color of our car to purple for every single car for the instance of the car that we have. So why is this an instance method? Well, again, remember, self is our important keyword that only refers to a specific instance. Yeah. So also, I'm going to go ahead and add in the year just to make it easier, just so that we have something else to play with. So let's go here and let's say that this is going to be like 2020, and this one is going to be like 1984 or 1983. So let me comment this stuff right here. Yeah, we can keep all of this honestly, and we can delete that. So a static method is trying to think about what a static method would be for a car. Okay, yeah, sure. Let's say we have like a welcome message. So for whenever a static method is basically something that we define outside of a specific instance. So again, here we have an instance method, which again calls back to self. And a class method is something callable outside of an instance. So the way that we can define a class method, or actually here, let's start off with a static method. That's probably easiest, then we can do class after. So the way we define a static method is by just using the @ sign and then just writing static method above our function. We can see here, if you guys want more detail, that static methods convert function into static methods. They do not have a first argument. So like for our instance method where we're calling self, we do not do that for static methods necessarily. So for our welcome message static method, for example, we could say our welcome, this is going to be print like welcome to. So how exactly do we use static methods? Well, again, static methods work independent of an instance. So what we can do for example, we could say forward car dot welcome message, like so. And here, let me comment this out. So what am I doing in my print method? Well, I'm saying I'm going to the class of forward car, which is this guy. And then I'm printing out, referring to welcome message, which is this thing, and then it'll print out welcome to full. So if I run this, click, let's run, there we go. So by going to welcome message, it's part of the class, but welcome message is not tethered to a specific instance of our forward class. So for example, if I ran, let's say my car, and then we did my car dot welcome message, and we run this, it should still give us welcome to forward as it does. Why? Because this is still a method of the class, but we don't need to define a new forward car to run this welcome message. We don't even need to define an instance of the class. We can just take the class like so and refer to using the static method. So we don't need to create a callable outside of an instance / no instance necessary. Now, this is different from a class method. Let's see how. So let's say I need to make something that always creates green 2023 cars. So, and that one will input class like so, and then up here we're going to say class method. So what is the difference between a class method and a static method? Well, again, let's read over what VS Code tells us and try to understand it. So it says it converts a function to a class method. That's great, doesn't tell us anything. A class method receives the class as an implicit first argument, just like an instance method receives the instance. What does that mean? So if we go up, if we go up here and we look back at our instance method, remember that our instance method takes in the keyword self when we're defining it. Why does it do that? Because the instance method does stuff with the specific instance that we're referring to. And self, as you'll remember, is going to be our instance keyword. So for class methods, they do things with the overall class and not tethered to a specific instance necessarily. So when we're defining, say, this 2023 car, we're going to use the CLS keyword, which, again, it basically acts as self, but for classes. So let's do that and put a colon. And what can we do with this? So this one, let's say that we're going to create a new green 2023 Ford. So this will return, let's say, CLS. So it'll create a new Ford car that is green and from 2023. So what can we do with these class methods? So ordinarily, if I wanted to set up a car that is green and from 2023, I have to set it up this way, right? I have to say Ford car, then green, then 2023. But instead of that, what I can do is say, my car equals Ford car dot green car 2023, or green 2023 car. And if we, let's say, print my car dot color, and then we also printed my car dot, where is here, we should see that the color becomes green and the year is 2023. But don't just trust me on this. Let's actually run it and see what happens and make sure it works. Okay. I just realized we have extraneous statements here. Let me remove those prints. Perfect. Yep, so we see my car.color prints and it prints green, and my car.year prints and it gives you 2023. Now, why does this work? So let's walk through what each line of our code is doing. I'm creating a new variable called my car, and that's equal to something relating to the Ford car class. We don't know what yet. So it's going to go to Ford car and be like, all right, what do you want me to do with Ford car? Then it goes to say green 2023 car. All right, what is that? That is a class method. So green 2023 car takes in the class, which is Ford car. So the only way I can't just run green 2023 car like this because it's not a normal function. It's still defined within the scope of our class, and it takes in the original class as a necessary input. Now this returns a new instance of the Ford car class, right? That's why we have CLS, and we're defining this instance of the class as having a green color and a year of 2023. So this does not, however, change things for if we make a new car. So for example, if I were to make like this blue car down here, and we did this exact same print statements of color and year, and let me just copy blue instead. We see here that the blue car's definition still stays the same, but my car here has been instantiated using this class method to be a new definition for our class. So once again, going back up, instance methods.
Question, Umar.
Oh, go ahead. Yeah.
Do you need that decorator every time you define a static or class method?
Yes.
Thank you.
Yep. And again, if you just want to see why, well, if we run this with welcome message like so, this I don't believe should work, but let's double check. And here we'll hit run. Nope, never mind. That did work. Well, in any case, for the static methods, it's definitely a good idea to include this decorator because I've definitely seen issues before where when this was not included, this just would not run. For class methods, you also need the decorator because if we remove it, the CLS parameter does not always self-recognize either. So saying class method there is basically necessary.
And we're going to want to use it for every method.
So
if I have
every
multiple
time that
class methods.
Yes.
All right.
So
thank you.
and here's why. So I can easily move. Well, let's say that I'm creating a new class method down here. Let's say that I've got my make it purple or my make it purple method here, and I want it to be a class method. However, if I don't say at class method down here, we don't necessarily know that it's a class method. I mean, here I'm defining it as an instance method down at the bottom. So by adding that decorator every time we define a class or static method, that will basically clarify any confusion as to whether the method that we're calling is instance, class, or static. So always use that decorator every time.
Got it. Thank you.
Can you explain again what cases you could use a class method in? Like in this case, this is assuming to create new instances of a class. What other examples there could be for a class method or uses?
That's basically the only usage of a class method, as far as I've seen, is just creating specific subtypes of a class. So again, like in this example, we could create like another class method if we wanted to create cars from 1984 that were blue, for example. And for larger, more complicated classes that don't just have 2 inputs, but that have like, let's say 20 or 30 characteristics, using these instance methods is really helpful. So that way, instead of just handwriting every single time you need to create a new version of this class, everything that went into it, you can just run your class method and create a new pre-filled almost version of the class. That's about the only use for class methods, really, is just creating new instances of that class.
Cool, thanks.
So would you use that like to make like a sedan or a truck like inside of the Ford car class? Like, is that something you would use that for? Or
You could. In this instance, though, it'd probably be easier not to do that and just do that within the init method. So I guess here we could say like, here, let's go here and we could say like, we could add like type in here, right? So we could say like self dot type equals or here, let's say type of car, because so just because we can't really define a car only on its type, we still have to input that color and year. Let's say that, we've somehow ordered a bunch, like 100, like 2023 black Ford Broncos or something. So what we could do is say define black 2023 Bronco and make that a new class, and then say return CLS black 2023 Bronco. And then every single time we run that function, we get a new black 2023 Bronco out of it. And yeah, we need to put the class method up there, obviously. But you wouldn't just use this just to generate like an SUV every time. If you were to do that, you'd still have to input the color and year into your class. Any other questions? And yes, Don, so as you said, it's really easy to spawn specific types of enemies too, right? So a good example of that is, let's say you have just like a really big generic enemy class, and you've got all sorts of subtypes. You've got like, your ranged enemies, your infantry, your, I don't know, other things that are coming to mind. And if you needed to spawn, let's say like a wave of like 20 of a specific type of infantry, you could just run like a for loop that iterates from 0 to 19 or 0 to 20, and then each time just create a new enemy dot and then whatever subtype of enemy it is.
I see the blue car example. I said, can I see the blue car example? I remember your second, blue car. Okay, that's it.
Yeah.
Okay.
Hey, Umar, can you just go over the static method and how it can be called outside of the instance? Because I got a little confused because you were using an instance to call it. So,
sure. So yeah, and I see some questions in the chat about the difference between those two. So the static methods do not change an instance or a class. The static methods are basically just there. So like the main use case here, let me comment all of this out too, as we don't really need that right now. Okay, cool. So all of that's commented. Let's make some space. So our static method here is our welcome message, and that just says welcome to Ford. Now, this does not take any inputs in this specific case. We could make it take in an input. We could make it take in like the input of name. So if I were to run welcome message and then put in my name, for example, it would say welcome to Ford over. Now, the welcome message here, because it's a static method, the intention is to run it just using the class itself. So when I say Ford car like this, I'm not creating an instance of Ford car. I'm not even referring to anything specific within the class itself. I'm just saying that I'm calling this method called welcome message from Ford car. It does not reflect an instance or the class itself. So again, if I were to run this right now, once it runs, it says welcome to Ford. Or I should probably put a space in there. But I can't, the reason that we have this as a static method is I can't just run welcome message or like this, because it's like, hey, I don't know where this welcome message is coming from. But because we define welcome message within Ford car, it's still only defined within the scope of Ford car. The only way we can run that is by doing this Ford car dot welcome message. So static method here is not dependent on a specific instance of the class, or it's only depending on like the class itself existing, because that's how we call it. In contrast, the class method both depends on the on the classic method, on the class existing, but also being used to instantiate a new version of, or a new iteration of that class. So if we wanted to say again, like my car is Ford car dot green 2023 car, right? Because this creates it goes to the Ford class, the overarching Ford class, picks out this class method, and then it creates a new version of the class when you call that method. So the static method sort of exists within the class, but doesn't require an instance. But the class method exists within the class and is used to create / modify an existing instance without being dependent on the instance properties.
So if we had like, say, a recall message, so like if all Fords used like one part, something broke, and then we had a class method for like the recall message. So before anybody knew that this part would break all the time, it said no recalls. And then people start finding out that the part is faulty, we could change it for every class or for the whole class.
Right. So that would probably be best as like a class variable. So we could have like a variable set up here and we could be like, is recalled, and we could just say that's false, capital false. And then later on, right? So that would set for all the Ford cars, because it's a class variable, it would set is recalled to false for everybody. But later on, if that recall does happen, you change it for one car and you say is recalled as true, it changes it for all the cars. So everything gets recalled. Does that kind of make sense?
Yeah, but I mean, if we wanted like a particular message, so it would say like this part is faulty. And so it would let every instance of the class know that this part is faulty, right?
Okay. I think I get what you're saying. Yeah. So what you're saying is like saying like this part is not broken, and then later on, like some point down the line, change that message to saying this
Right.
part is broken.
Mm-hmm.
Yep, yeah, that would work, and that would change this message for every single instance of that class.
Or like a list where you could keep the recalled parts in for that class.
Yeah, you could do that too, right? So here we could say like recalled parts, and then you could add to that list of recalled parts for every single instance, and then that would just create a massive list that applies to all the things under this Ford car class.
Hey Umar, I had a question about the class method. So in your init method up top, if you put plate number back in there, like in the parentheses, and then tried to run your class method, like green car, like create an instance, obviously the class method only passes in color and year. So it's coming back for me like as an error, like I need plate number in there. Is there a way to do that where it doesn't send back an error and just kind of gets it started with the green, the color and the year, and then leave the plate number blank for now?
So you're saying like do something like South God. So you're saying like using this framework, right? Basically.
Yes, yeah, that's what I'm
Also,
talking about.
Okay, gotcha. So the reason that we're getting that error is this is essentially by running this class method CLS green 2023, this is identical to defining new instance of Ford car with green and then 2023. But the problem is it doesn't have the third input that we need is plate number like this. So it's going to naturally throw an error when that happens. So we could do to make this an optional parameter, we could set like a 1, 2, 3, 8. We could temporarily set plate number to like a default value. and then that wouldn't require plate number to be input.
Okay.
And then you probably would not get this error. And yeah, Michael, we're going to take a break once all the questions wrap up. All right, any other questions about instance versus class methods versus static methods? All right, I think it's probably not a bad time for a let's say 8-minute break. We'll come back together at 10 things back off. Okay, that is back. And let me find my slides again. All right, cool. So welcome back. To recap everything we just did. So we started off by talking about classes and instances. We talked a little bit about class attributes and class methods. So remember, class attributes are the same for all instances of a class. If you change it for one instance, you change the class attribute for all of them. And class methods can be accessed by all instances of the class, and they can also be accessed or used to create brand new instances. Instance attributes and methods, as it says here, they can only be accessed by an individual instance, and changing instance attributes only change it for that instance, not like class attributes. Also, lastly, we have static methods. Remember, your static methods are things that can be accessed by the class and by calling the class and an instance, but it's not really supposed to be. The class or the static methods do not create new classes, unlike a class method. They just do stuff that live within the class. So now that you guys had a little bit, like 10 minutes or so to think and ponder or just take a break, do you guys have any other questions about class/instance attributes or methods or static methods
I had a
before we
question
jump
about the
into
memory. It's not like super memory intensive, is it? For those class attributes. Like if we were to create a big list at the top, that thing only lives in the main our parent class object, I guess. It's not saved like in every instance, is it?
I don't think it should be saved in every instance, but I'm actually not sure. Francisco, any ideas?
Yeah, could you repeat your question again, Jesse?
Yeah, so if our car example, we had a parts recall list, it's going to be gigantic. Is that just like saved in the parent class object and then all the other instances reference it? Or is it saved in the instance itself and then like somehow continuously updated?
Got it. Yeah, no, so it's not saved into each individual instance. It's actually saved into each independent class. Anything that belongs to the class relates strictly to that class itself, and anything in the instance will then reference to the instance when it comes to memory and where it's being stored. Does that answer your question? Okay, perfect.
Awesome. Thank you for that, Francisco. Okay. So any other questions before we get back to more new stuff? Okay, no new questions.
One more.
Never
I
mind.
have one question. Do you have any? Do you know of any like interactive websites or things that we can use to practice classes and instances and stuff?
I mean, I know that you can probably like if you're looking for like practice problems, don't worry, we're gonna have a lot of practice problems coming up over the next week, and definitely a few modules that talk about this in your daily problem sets. Outside of that, I know Khan Academy generally does a pretty good job of having like videos about this stuff, and I believe they have practice problems too. You could also probably look at websites like LeetCode as well. Yeah, that's generally what I would recommend.
Okay.
And sometimes I don't know if I don't believe we have anything linked to the bottom of today's unit, but also sometimes we will link to like good places for practicing or that have practice problems and stuff, especially as things get more complicated at the bottom of the daily readmes. So feel free to look out for those as well.
Okay, thank you.
There's 3 assignments at the bottom of today's curriculum, isn't there?
Yes. Yep. So there's going to be app users 2, contact list, and Caesar cipher. So those are going to be your afternoon challenges. All right. Last call for questions. And you guys can ask them at any point, of course, but before we move on to get and set methods. Okay, so this goes back to a question that I believe Pete asked earlier about how to avoid people just going in and messing up your variables randomly, right? So this is where getter and setter methods really come in handy. So getter methods specify how somebody can get or access an attribute, and setters specify how somebody can change the value or set the value of that attribute. So let's go back to VS Code. So let's say, here, let me remove the plate number for now. We'll just go back to this and we'll take out the dryer. We can keep those, it doesn't really matter. I'll just remove recall parts for now. So let's say that, let's say we don't want anybody to be able to modify the year category, or that let's say we want to set the year of your car. Actually, no, that's not a great one. Let's do VIN number. VIN number is probably better for this. Let's say VIN number, and then we'll set self.VIN number equals VIN number. And here we'll just say, I don't know what a VIN number actually looks like, so I'll just put in a random number. Yeah, that should work. And we can delete this and delete all those for, okay, we can keep those for now, I suppose. All right. So let's say that we have a car that's got a color, it's got a year, and it's got a VIN number. And then it's got this other thing like different models and drivers and whatever, but we don't really need to worry too much about those. So for our VIN number, a VIN number is something that generally we don't want people to be able to change, right? That's why VIN numbers are, at least from what I hear, a big deal. So how can we restrict VIN number so that once you set a car's VIN number, it becomes really difficult to change what it is? And that is where getter and setter methods come in handy. So as I mentioned earlier, Python doesn't really have a notion of what a private variable is. So unlike in other languages. So you can't lock or set or make private the value of a variable in Python, unlike in, for example, C or Java or another, I guess, older, more traditional language. But we can use a notation to privatize a variable, at least on site. And that is simply putting an underscore before. So when we're defining VIN number for self, we're going to add an underscore and then write the name of our variable. So no, adding underscore does not privatize variable only notation. So this way, if somebody's going through your code and they see that you have this variable or this attribute of your class with an underscore, they'll be like, okay, I know that this attribute is supposed to be private / locked. It does not actually privatize or lock your variable. It just sets it. It's just a notational thing. So that way, when you're going through it or somebody else, they're like, okay, I get this. So right now, and again, we can show that, right? So let's say I've got my green car that I made. It's got a 1234 VIN number, and we can check that. We can say my car dot underscored VIN number. And if I run this, it prints out our VIN number, which is 1234. But we still have a problem that I can still change my VIN number. So if we go to the next line, we can say my car.VIN number. Let's say it's going to now be 5678. And we print out the same thing again. We see here that we're still able to somehow change our VIN number to 5678. That shouldn't be happening. So this is where our getter and setter methods come in handy. So here we can let's define our getter method down here. So getter method gets our VIN number. That's really all there is to it. So the first thing that we need to do is say that this is going to be a property attribute or property method. So if we read about what VS Code tells us, it says this is a property. It's a managed attribute. That's about all that it says. But let's see how this works in practice. So if we'd say at property, then we are going to define, what did we call VIN number? We can just call it VIN number and then self. So we define this very similarly to an instance method because again, a getter method is an instance method. Instance method. And then all we need to do here is return self.VIN number. So what does this do? Well, this way, we don't actually refer back to the original variable in our class for VIN number. We refer to this getter method function if we want to print out the VIN number. So why is this difference important? Well, let's say I'm a normal person and I'm accessing this class. I'm not going to think that VIN number is something private. I'm going to say, okay, VIN number is probably written out like a normal variable. So instead of printing out this underscore, I'm just going to print out regular VIN number, like so. Here, let me comment these lines out. So if we do my car.VIN number without that underscore, this dot VIN number goes up to our property line. It goes up to here and returns self.VIN number. But know that this is a property, so it's not really a function per se. So we don't run it like we would run a function. And if I run this code, once it loads, again, it goes to my car.VIN number. It goes up to here. It returns our self.VIN number, which is our privatized variable. Again, it's not really private. And we know that we define that VIN number as 1234. But let's say that now I'm like a bad person and I want to go and change that VIN number. Well, what I'm going to think is when I see my car.VIN number written like this, does VIN number here, VIN number doesn't look like a function. It doesn't look like a getter method. It looks exactly like a instance attribute. So I'm going to say, my car.VIN number looks like it's just accessing the instance attribute. So I should be able to run my car.VIN number equals 5678 and then change the VIN number to 5678. Let's see what happens if I try running it this way. That's so weird. It says my car.VIN number equals 578. It can't set the attribute of VIN number. Why is that? Well, again, remember, VIN number without the underscore refers to our getter method. It does not refer to the original instance attribute of VIN number. So this way, it kind of, I guess you could say using this getter method, like so kind of secures your your instance attribute here that we don't want changed from being changed. However, I mean, if the person's smart who's trying to hack this very simple database, they'll just put an underscore in there. Again, you can change the underscored VIN number because the underscored VIN number is our instance attribute. And oops, let me run that. Again, we see we can change the instance attributes. by using that, changing the underscore, and then that gives us our 5, 6, 7, 8. But if we just run it with this regular dot notation, this goes to our property, which we can't change. It only gets it for us, and then that works. And yes, Eric, this is an example of abstraction. So this is how we can use a getter method. Now, we can also do the exact same thing for a setter method. Let's see, Dakota, for as long as the user knows the instruction, we can always access. Dakota, yes. Unfortunately, that is correct. I'm pretty sure that there are Python libraries out there that prevent this from happening, or make it more difficult, but I don't know what those are. They may exist, but in general, like in terms of 99% of default Python code that you will write, if you have a class, you can access any instance or class variable within that class from outside of it, as long as you know the name, which is a little bit of a security problem, but that's something for a very different time.
Is there a method to like encrypt stuff like this, or not really?
So yes and no. So you can't really encrypt the attribute itself, unfortunately. But you can encrypt the value inside of it. And that would be using something like a hash table or like an encryption algorithm like RSA or public private key, something like that. But you can't encrypt, like I can't encrypt self.vin number like that. I can encrypt whatever's inside of it and have a decryptor method, an encryption method or whatever, but you can't encrypt the actual variable itself.
Sorry, just ridiculous question. What if you had like a variable that was just like a bunch of numbers, I guess a transfer variable between that the class and the other variable you're using? Something unguessable, basically.
You could do that, but there's still no way to encrypt or to prevent access to the variable. So like if you had like a separate thing like in this format and you created another variable, a self.vin number here is you can still get the original VIN number because that's not encrypted. Anybody can access that. And yes, so Dakota, yeah, it's basically just a like, hey, please kindly keep your hands off of this thing that you should definitely totally not touch. But you can't actually prevent somebody from going and messing with it.
Hey, Umar, so as far as this lecture goes, then what is the point for us to know these getters and setters? I mean, unless we're using that Python module, like you said, that makes it, hard to know what the instance variable is.
Yeah, so at least I'm sure Francisco can probably speak more to the purpose of its inclusion here than I can, but the purpose of this is just to get you familiar with this module is to get you familiar with methods that you will see in Python classes overall, and you will often see getter and setter methods being used. So this is just like a familiarization exercise, but in terms of like practical application, it's kind of like a low tech way to secure something like a tiny little bit more. But also, if you have like a variable, having variables with underscores is kind of ugly, and you don't really want to. You don't like if I'm just writing the bulk of my code, I don't really want to calling something with an underscore with like dot underscore notation. It just looks kind of ugly, to be very honest, and people don't really like seeing that. So instead, you can use these getter setter methods to, clean up your day just a tiny little bit as well. So, but yeah, there's not a huge practical benefit in terms of like if you really want to secure something, then there are other things that we'll talk about for sure later on. But I guess it just like helps a little bit, if that makes sense.
It does. And then just to clarify, the underscore is just for other developers to know that that attribute is supposed to be private.
Pretty much, yeah. It's just a like, this is supposed to be private. Please do not touch this thing. And yes, Francisco.
Yeah, so the main reason why we try to ensure that we, at the very minimum, introduce this is because, as you guys spoke to many of our alumni, most of them were thrown into different code bases with different languages, right? Something like C# or Java do have a very strict private method or private setters that they can tell them, hey, this is private, you cannot touch this. And it's important for you guys to get familiarized with the concept of something being private and how to work with getters and setters, because nothing guarantees that after you leave this bootcamp, you will end up in a Python environment. So at the very minimum, we want to ensure that you understand the concept, because if you, for example, when I picked up C# for the very first time and that was introduced, it was very easy to grasp the idea because I had already learned it when I went through the bootcamp and learned it in Python.
Thank you. Of
course.
Yeah, and adding on to what Francisco said, Python does not have, it has a lot of features, but Python's also designed to be a simple, easy to use and easy to implement language, unlike C# or Java, which have a lot more confusing stuff behind them, like memory access and memory limitations and public and private variables and other stuff. So this, because of the limitations of Python, we can't teach all of that in like the same way that we would be able to if this was like a C# or Java or some other like programming language specific thing. But the goal is to be able to put you guys in the mindset to start thinking about those issues and to make it easier for if you are placed in a role that use those languages to be able to understand how those language or what those concepts are in an easier and I guess more palatable manner, if that makes sense.
Yes, thank you.
So before we wrap up the getter and setter methods, I also want to talk about setter methods because that's kind of the other half of this. And then we'll move on to decorators and then we will be done. So just like a getter method, setter methods basically just set your properties. So we could say like set the VIN number, which is again also going to be an instance method. Now for this one, we're going to define it as using a decorator. So see, I guess this would be VIN number, because now VIN number is a property. We're going to say VIN number dot setter is going to be our decorator. Because again, now VIN number here, we have the @ for property. Then we're going to be saying that the method we're defining here is going to be a setter method for this property. So we will say define VIN number. We're going to use the exact same name as we did for our getter method. And that's going to be self. And then we could say like new VIN. And then we could just say something like self dot. Now remember, we can't change the property directly. So we have to change the instance attribute, which uses the underscore. So self dot underscore VIN number is going to equal our new VIN. And that's about it. So remember how before we had this setter method, I said that we wouldn't be able, that this my car dot VIN number like that wouldn't work because it says you can't set the attribute VIN number because it's a property and that only had a get method. Well, now that we have a set method for that property, this my car dot VIN number equals 5678. If we run that, and I'll go back to our VIN number here, and we see here that this says VIN number dot setter. What that means is whatever this function does is going to change whatever this thing refers to. So by running my car dot VIN number as 5678, we say, all right, so self is going to be the old VIN number, and new VIN is going to be 5678. This thing has the authority to change self.vin number because it's a setter function of this property. And then we can change the attribute VIN number to our new VIN of 5678 without any errors. And let's just run that to double check that this works. Yep. So again, the old VIN number is 1234, like we set up here. Then we can, using our setter method, we set it to 5678, and it prints out successfully. Now
Can
again,
you use that VIN number setter like a function where you pass 5678 as an argument?
yes. So 5678 here is an argument for our function. But the way that we use this function is, again, because VIN number without the underscore is a property, we use the equal sign to set that instead.
Okay.
But
You
it's still a function.
so you can't like directly just type out like my car dot VIN number parentheses the new VIN. That won't work.
I'm not sure. Let's see. We can always try this sort of stuff with syntax. Okay, yeah, so that turns out that doesn't work because it says down here again we get a type error. This int object is not callable. So that looks like it broke.
Okay. I was curious. So you can't like directly call the setter function. You have to call the getter, which then calls the setter. Is that essentially what's happening?
Nope. So we don't have to call the getter at all. So like this my car dot VIN number, like it in that print statement, we don't have to do that. But the way, oh, I guess you do raise a good question though. How, if I'm running my car dot VIN number, how does it know whether it's running the getter method or the setter method, right? So when I'm running it like in this print statement here, getter method, setter method. The way that we know that this guy is running the getter method is because it doesn't take in any inputs. It doesn't have this equal sign and setting that property to have a assigned value. It's just saying, all right, my car dot VIN number. And that's where having the property and the setter tags come in handy. Because in our original definition of VIN number here for our getter, we only have it take in one input, and that's self. And self here is just basically going to be like my car, right? It doesn't take in any other inputs, so it's automatically only going to get the property. However, in our second statement where we set my car dot VIN number equals, it looks at that equal sign and says, hey, I can tell that I need to take in another value. I already know that my car is being passed into VIN number, which satisfies the self condition. But I'm also going to take in some other parameter because it has that equal sign. Now, because I'm taking in this other parameter, which is 5, 6, 7, 8, I'm taking in two parameters to my function. I'm taking in self and this new parameter. Now, two parameters can't be taken in the getter method. That only takes one. So I have to use the setter method. So that's the way that it sort of demarcates between the getter and setter methods.
Quick question real quick. So say you had like a long list of new VIN numbers that are associated with already cars that you have in your thing. What would be a method of setting multiple VIN numbers at once?
I guess what I would do is, so you could have, let's say, a diction. So I guess what you're saying, Ethan, is like if you have like a dictionary of like VIN numbers and cars, or like a list of VIN numbers and then a list of cars. Is that right?
Yep.
So I would just iterate over either the dictionary, or if you had two lists, create like an iterator, or create like an index iterator, and then just say, actually, we can just write it out. So let's say we have a list of VINs, and then we have a list of cars, and then we could either make those dict or not, and we could say like for I in range 0, comma, length of list of VINs, then what I would just say is something like list of cars of I dot VIN number equals list of vins I, and basically just go down the list and manually set that VIN for each car. So there's not really a way to do it for all of them simultaneously. You kind of have to still go one by one.
Okay, that makes sense. And there's no way of putting that in the setter function, obviously. I mean,
No.
you could.
So again,
yeah, okay.
Yeah, because again, the setter methods are still instance methods, so they still operate instance by instance for your class.
So with getters and setters, do you really only use them when you have that underscore in the instance attribute name? Or would you also use them if you weren't using that underscore at all?
Honestly, you really would only use them if you have a variable that you want to keep private. Like again, like your VIN number, like the original VIN number here, like with that underscore, because you want to keep that private, you don't want people accessing it directly. That's the only case that you'd use this. And I mean, here's why, right? So let's say we had some like global variable here that was like am I a, or let's see, I am dealer. And let's say that, that says, hey, the person on the other end of this, are they a dealer or are they like a normal person? And what we could say is something like, inside of your function, like if I am a dealer, then you can change the VIN number. Otherwise, you can't, right? So just like a very simple, like setting permissions. And we can see if that works here as well, right? So say I pop this guy over here, we set that, yes, this user of this program is a dealer, and wait for my computer to decide that we would like to run Python. So it changes it, right? But if we say, let's say that you are not a dealer anymore, and I'm just like a normal buyer, then it won't change the VIN number using this. Versus, if we wanted to just like change color, for example, something that we don't need to put permissions on, we could literally just type myColor.color equals like purple. So the getter and setter functions are only really useful if you want to like add a layer of security of sorts like that. But otherwise, you don't really use them.
I had a question. So like is there really any difference in like using, like if you just made a method that said, def return VIN number or get VIN number, and then you just said like return self.underscore VIN number, is there like really any difference? It's just you're not tagging it as a property in that way?
Pretty much. So what you're saying is basically make a function like this, right? Yeah, so this guy, and this guy do exactly the same thing. The only thing is you just call them slightly differently. So like here for your getter, you're saying my card.VIN number like that. But for the other one, you just have to say my car.return VIN and then call it like a function because it is a function now. But yeah, I mean, for both of those, like if I didn't have the setter method, I wouldn't be able to say like my car.VIN number equals. But similarly, I can't say my car.return VIN equals like 5, 6, 7, 8, right? Because this is a function. And saying expression can't be an assignment target. You can't say that the output of function equals something.
Okay, yeah, that makes sense. Thanks.
Yep. And yeah, as Francisco said, you can't create a setter without a getter being set because, again, if we go back to this guy here, we're having a setter method. The setter method has a decorator on it, which is going to be the next and last thing we talk about. Like setter method's decorator refers back to the property set up by our getter method. Any other questions? Okay, so let's move on to our last topic, which is decorators. So I'm just gonna comment out all of this stuff. Okay, let's keep that. And go down to the bottom, and let's say decorator. So decorators basically allow us to modify how a function works or runs. Personally, I like using decorators a lot for testing purposes, because honestly, they're great for that. Let's see, what are other important things? Or here, actually, wait, let me see if I can go back to the slides. I think that had an example of decorators in there too. There we go. Yeah. So it takes in a function as an argument to modify its behavior. And we see that it does so using that little @ sign. We've already seen a couple of examples of decorators so far, right? So you've got your static method decorator, your class method decorator, stuff like that. So let's go back to here. What's an example that we could come up with? So here, I'm gonna see let me refer back to my example demo that I did for decorators. Where are you? Oh, perfect. Okay, there we go. So let's say that we want to, so again, decorators are really useful for testing. So let's say that we wanted to create a function, that takes another function, or that prints done when another function finishes run, right? Like as a test thing. So the way we do this is we have for our decorators have two components. They have like an outer component, which is the way that we actually call the decorator, and then an interior wrapper. So let's say that we say define print done, and then we're going to say that this decorator is going to input some function. And then inside of that, we have to define a wrapper function. You can call it a wrapper function, or you can call it like actual. I'm just going to call it wrapper function. And then here we're just going to basically just run your original function, and then we'll just say print. So, oh, and then the last thing we need to do, I forgot about that here, is we need to return the wrapper function. So what did I just do? This does honestly seem kind of confusing at first. So let's say that here, let's make a sample function. Let's say define say hi, and then we'll just say print hello world. And now I'm going to make this a decorator using print done. And if I run, let's say hi, and here, let me move this, I can access my console and wait for it to run. So we see here that it runs our hello world, but then it also runs done. So how does this work? So the first thing that it does is it goes to say hi, and then it says, okay, I know say hi is going to be a thing that's created, a thing that's created by our print done. So what is print done? Well, print done takes in our say hi function as an input, then it does stuff within our wrapper function. What does our wrapper function do? Well, the first thing it does is it runs our original print done or our original say hi function, and then it prints done, and then it returns, well, this guy. So it basically runs this. So if we wanted to diagram out how this works, so call say hi. From there, it's going to call print done. So then that's going to create our wrapper / helper function. It's going to run original say hi function. It's going to print done. And then it's going to, or here, let me space that out. And then it's going to run the wrapper helper function. Does the general outline of this make sense? I understand. I know that this is definitely really confusing, and we will not see decorators used very often, but they're used a lot again, especially in terms of testing things. So it's good to have an idea of how they work.
Can you go back to line 104, right? It's call print done. What is it passing in, right? So you see like a func is being passed in.
Yes.
What is that?
That is passing in say hi.
Okay,
So the
it's passing
original
in.
say hi function is going in as an input.
Okay.
It seems kind of redundant because why do I need that decorator? Can't I just define the print done function and then the say hi and then just pass it in directly without the decorator?
So we can try that. Let me get that, do this, and then we'll just do that. And we can say print done, say hi, like so.
Yeah.
Okay. No, let's wait for it to run. Yeah, so now we get a problem. So it comes up, so by running print done, say hi, right? I'm inputting the function. So hypothetically, what should happen when I run this, at least what we're thinking is, it'll run print done, and say hi is going to be our input into our function, right? The only problem is if we run this, we're inputting say hi in here, and it should be running that function, but it's not actually running it because it says that none type object is not callable. So we get an error if we try to run this function within another function like we're doing here. So to avoid that, the way that we're using our decorators is we have to use a decorator in order to run these functions within each other, like using this framework.
Real quick, just this might not work as well, but I'm just curious if you tried passing in say hi to that print done function without the parentheses after say hi, would that work? Because within the print done function, you have func followed by the parentheses. So you already have the parentheses in there. If you tried to pass in say hi without it, would that work?
Yes, that does work.
Awesome.
So, all right, well, decorators are useless now. I'm kidding. So yes, you can use it. You can do that this way, and actually, thank you for catching that syntax error. In general, though, it's just not. People generally don't like using this syntax for it, I guess. One, it doesn't look as clean to say like print done and then say hi like so. It looks a little bit better when you're running it to just run the original say hi function with that decorator. But also, this doesn't, the other benefit to using decorators is it allows us to run the helper function on functions that take in multiple inputs, which is really where decorators sort of come in clutch. So to back up and explain what I mean here. So we've got our say hi function here, right? So say hi right now, it doesn't take in any inputs. Now let's say instead that we change say hi to have my name as an input, right? Say hello plus my name. And then we have say hi to Bob. So if we run say hi Bob right now, this will not work in the current framework. Why? Well, the first thing it's going to do is it's going to call say hi, right? So it's under our print done framework. We're inputting our function, our little function. Then it's going into the wrapper function. It's running function. But wait, I don't have a way to specify what my inputs are to this function in the current schema. I can only input the function of say hi. And I don't know what to do with Bob. So it's going to break when it runs it. And just to prove that to you, let me run this real quick. And as you can see here, it says print done dot locals, where this is a local function within print done dot wrapper, takes 0 positional arguments, but 1 was given. What on earth is a positional argument? A positional argument here basically just means the thing that I'm putting into this function. I haven't said that wrapper is going to take in any arguments, so it can't pass any arguments to function, so this breaks. But I could say, for example, that the wrapper function is going to have a name that I'm going to put in, and then we run func name. And if we run this, now it works. Why does that work now of all times? Well, again, what are our inputs? The input to print done is just the say hi function, forgetting that Bob exists. The input to the wrapper function is going to be whatever we're inputting into say hi, which in this case is Bob. So calls say hi, calls print done, input is say hi, calls the wrapper and helper function, input is whatever we input into say hi. Then that runs the original say hi function with original inputs, and then it prints them. So the main benefit behind using decorators like this, instead of the schema that we talked about before, where we could basically just define print done, not have the wrapper, and just use function, is the decorator schema allows us to run the function that in question, in this case, our say hi function, and have it take in inputs as needed. So instead, if we go back to that original example that we talked about, where we had a define print done, we input in a function, and then we just ran function. We don't have a way to take the inputs of this function anymore, because yeah, we just have one line here. And I can't run the function because I don't know what parameters it takes. In contrast, using the decorator, we have a built-in way using this, again, custom named wrapper function to take in our arguments and inputs. So that's where the original simple idea of just creating the define and then running your function kind of breaks down. So any questions about why decorators work?
I have a question. So
Go ahead, Chris.
Oh, so I have I guess a couple of complex questions I'm trying to put in words essentially.
Sure.
So could we actually call functions from like different classes? Like in an if statement, like take one class or another class, or even like use multiple classes functions with each other? Just curious.
So what you're saying is, like, if I have like a class method from one class, like to apply a decorator to that?
So let's say we were to try and create a third function, but you had multiple classes, but you wanted to use functions from 2 separate classes. Could you use them together in some sort of formula of any sort? Like, or can they only
Yes.
be used?
Yeah, you would be able to, I guess, sort of combine them like this if you wanted to.
Umar, can I just kind of like my thought on this, right? So the say hi can be called, but it will only run within the print done function, meaning I can call say hi, but it's not going to run independently. It's only going to run within the print done. But the
Perfect. Yes.
but print done can be called from another function and can be ran outside of the say hi. So essentially, say hi only runs within the context of print done, but print done, if called by itself, can wrap other functions if called.
Yes.
Okay, got it.
Yeah, so that's hence the name of the interior there as the wrapper function, right? So say hi when you create this app print done by applying that decorator, it automatically means whenever I run say hi, I run print done. But the opposite is not true. Whenever I run print done, I can run print done with any other function out there, and it'll just run that function. It won't run say hi.
And the cool thing about having a decorator there instead of putting say hi inside of print done is that I can call say hi without referring to print done. I can simply say hi instead of putting say hi inside of the print done function, and then I won't be able to run say hi independently, right? Meaning
yes,
call it independent. Okay, got it.
Yeah. Also, a lot of times, again, we like using decorators for testing. So a helpful use case is I need to, let's say I need to check how long an algorithm takes to run, right? So what I can do is I can like print out, let's say you can use like the Python timing library to get the start time, run your entire function, and then print out the end time of that function. And then that'll tell you how long it took to run the whole thing. And you can have a decorator that does that really easily. Similarly, another good thing about decorators is we can customize the decorator. This is the last thing I'm going to say before we take a break, I promise. Is you can customize the number of arguments that your function takes in to make it versatile. So here, for example, we've got, I think Ethan may have alluded to this in chat earlier. So you've got your say hi function. Here we only have taking in one input. But let's say that instead I have a function that takes in 5 inputs. I don't want to hand write out 5 inputs in my wrapper function. So what I can do instead is say hash or say pound sign or star arguments, and then write down star arguments in here too. What are the star arguments? Star arguments basically means star args is all the arguments that I'm putting into this function and just like take all of the arguments. So if I have, again, here we've got the say hi function. I could easily say it's like my name, my age, my grade, my keyboard type, who knows what. And we could keep extending that. And now in here, I have to define all of those when I'm running this function, right? Like all 4 of these. Now the hashtag args basically takes, like copy pastes all of these things, puts them all in here, and then does the exact same thing down here. It takes all of these guys and pastes them in there. Yeah, that's basically it for decorators. Again, I know that these are really confusing, so lunch should hopefully help with a bit of a brain break. Before we do break, though, what questions about this do you guys have?
So I have a question about getters.
Okay.
I learned about getters before, and the syntax was a little different. They used a dunder method with the get and use getter that way. Is that different, or is that kind of the same way going about doing it?
Oh, that's a good question. So what you're saying is for the getter, yours looked more like like this?
Yeah, like that.
Okay, so that I believe just gets that isn't used to get like a specific value from what I remember. But I'm actually not overly familiar with how that works. Or did you guys use it to get a specific value? Or like a specific
Yeah, it
attribute of the
was from what I
class?
remember, it was like this was a little bit ago. We took FOP for like our functions. Every function had an init, and everyone had like a get with a dunder like that. And I think he used it to get like certain things within that you instantiate with the init.
Okay. Yeah, so in that case, I'm not too familiar with the dunder, getter, and setter methods, but from what you're saying, it sounds like it's doing the same thing. So I guess it's probably a slightly different notation.
Okay, thank you.
And Dave, to answer your question, so args are built in, and yes, as Jesse said, it lets you grab any number of parameters that you input. So if it's like if you have a function that takes in 1 or like 157, it grabs every single parameter in there and then just like drops them in that ergs variable.
Thanks.
Would that be true if you have 0 parameters for that function as well?
Yes. Yep. That would be. So again, it takes in.
Wouldn't you just want to always use star args then? And it's kind of like a default instead of trying to match it up with any function that it might be wrapping over?
I would personally say the answer is yes to that. Especially if when you're making a decorator, generally you want it to be as general or generically applicable as possible. So using star args and star quargs, which is more complicated, we won't get into that right now, but generally you will want to use those for your decorators.
Okay, thanks.
I'm confused with the line 94, the return wrapper.
Yes.
It's like the recursion, the return wrapper.
Say that one more time. Your audio cut out a little bit for me.
I said the line 94. 94
Yeah.
is here as the return wrapper. So the
Yes.
return wrapper is like a recursion.
Not exactly. So it's not recursive because it's not returning the original function. So return wrapper here, this is defined outside of the wrapper function. Like the return is outside of that wrapper. It's inside print done. So all of this this return statement is doing is it's just saying, hey, when I run print done, run the wrapper function. That's all it means for us. It's not recursive.
Okay, gotcha. Thank you.
Any other questions for right now? Okay, I'm gonna assume not, which is more than fine. Again, taking a lunch break is something I highly encourage, and that'll honestly probably help you guys a lot with processing things. So I'm gonna stop the